Hi, welcome to lesson 3.3. Today we're going to look at systems of inequalities. And a system of inequalities just looks like two or more inequalities written. And we're going to solve these always by graphing. We're not going to solve them algebraically. So the solution of a system of two inequalities is the overlapping region of the two solutions. So we could have one graph that or one line that looks like this, one that looks like this, and the solution would be if I say where I shade and have them overlap. So like this section. It's a full section, and that represents all of the solutions because it means that any point in this region, any point that's in here is a solution. So let's jump right in. Solve the system of the inequalities by graphing. Well, both of these lines are in white. So I'll use different colors for my lines for now. You can use whatever method you need to distinguish them. But I'm going to start by graphing my y-intercept of 2 and then my slope of 1. So I'm going to go like this. And if it's dotted, why we dot a line or make a line dotted based on the sign. If there's no equal to sign underneath it, then it's a dotted line. The other thing I need to do is figure out which side to shade on. How do we determine which side to shade? It's not just saying, oh, it's opening this way, so we shade that direction. Now we need to plug in a test point. My line does not pass through the point 0, 0, so I'm going to plug that in. I'm going to get 0 is greater than 0 plus 2, which would give me 0 is greater than 2. Is this a true statement? So I'm going to shade the side that does not contain the point 0, 0. So, but for now, instead of going like this and shading the whole thing, I'm just going to put little arrows to kind of show which direction it shades. Now for the other line, I will use a red for this one. It'll look kind of Christmassy. That wasn't my original intention. My y-intercept is 1. And my slope is -1. So I'm going to have a slope going like this. And then when I connect them, because there's an equal to sign underneath it, it is a solid line. I want it to extend in both directions fully to the edge of the graph. And then if I plug in 0, 0, because again, my graph does not go through that point, so it's safe to use. I get 0 is less than or equal to -0 plus 1. So 0 is less than or equal to 1. This is true. And so that means 0, 0 is a solution. So I'm going to shade below it or to the left, however you want to think about it. So when I shade, I'm looking for where do they overlap. And so some people will even draw like some lines to just help them. If you need to do that, you can. I like using the arrows because then I don't have to worry about like it's super messy or anything like that. What I can do is say, all right, for this red line, I'm shading either this section or this section. For the green one, I need to shade either this section or this section. And this right here is the only one they have in common. So the solution is going to be this section right here. And these are not solutions. They're not solutions because even though if I picked the point 2, 6, if I picked this point, it would be a solution for my first graph, but it would not be a solution for my second one. So it has to work for both of them. And that's why we only shade one section of the graph. All right, let's look at another one. I've got two equations in standard form. So when they're in standard form, I prefer to find my x and y intercepts. So if I have this, I'm going to find my y-intercept when x is 0. So I'd plug in 0 for x and get 2y equals 4, which would give me y equals 2. So I'm going to put that point on here. And then I would have, I did that backwards. I put y equals 2. or x equals 2 instead of y equals 2, and x equals 4. And this one has a line, so it's underneath it, so it's a dotted line. Putting my arrows on them. For the other line, I'm going to have 2x minus y is greater than 6. So I'm going to find these intercepts. And I would get negative 6, which means that y is negative 6. And then I would have x equals 6. So x would equal 3. X equals 3. And y equals negative 6. No line. Oh, I'm sorry. The other one should be it. My bad. Mixed up which line was where. Okay, this one should be this. Sorry, team. All right, so if I find my x and y intercepts, if I find my ordered pair and plug that in, if I'm using 0, 0 here, it's super handy because I'll just get 0 minus 0. So I'll get 0 greater than 6, which is not true. So for the blue line, I'm shading this direction. So it's going to be either this section or this section. So 0, 0 is not an option for that either. So it will go this way, and I'll shade either this section or this section. These lines act like boundaries. Here, but I only go up to the line. So technically I could, if I wanted to get real precise, I would be shading like, okay, I go all the way up to the line, but obviously I've told you, you don't have to worry about being super precise in your shading. Just make it clear to me what your answer is. All right, last one. So if I graph this first line, I've got a y-intercept of negative 3 and a slope of 1. No line underneath it, so it's a dotted line. And then I've got 0, 0. So 0 is less than 0 minus 3. 0 is less than negative 3. Not true. Shading this direction. All right. For the other one, this is absolute value. The number in front is positive, so it is going to open up. And since I can just do a translation. I've got x minus 4, which means that I'm going to shift to the right 4. And then I've got my slope of 1. Oh, I did Christmas colors again. It must be subconscious. And then this one gets a solid line because it has the equal to line underneath it. All right. So when I plug in 0, 0 to this, 0 minus 4. 0 is greater than 4. And so 0, 0 is here. So if I were to shade, I would have to shade inside, which means that the only place that my two graphs are going to overlap, if I look at my the red line and the green line, the red has to shade this direction, but green shades above it. The only place they overlap is going to be right in this middle section. So that might look a little bit weird to you, but that is the only place where they overlap, and that is where our solutions would be. So hopefully this has been a little review on how to graph lines, how to graph inequalities, and also on systems of inequalities. If you have any questions, please let me know.